How do autonomous vehicles work? Hey everyone, I'm super excited to be here today with Adam, and we're going to be doing a mock TPM interview. In this particular interview, we're going to be asking a question about autonomous vehicles, but before we get into it, would love to have you, Adam, tell us a little bit more about yourself.
Absolutely. My background is in mechanical engineering. I've been a technical program manager for about a decade now, worked across several different industries, including the government, consulting, and also now tech. And most recently, interested in autonomous vehicles and happy to be here and chat with you about it today.
Awesome. Well, we're super excited to have you. At Exponent, we believe in bringing the interviewing community together to make a more empathetic and guiding space. And so it's great to have an expert like yourself on the show today. So without further ado, let's jump into it. In today's question, what I'd like to ask you is, how do autonomous vehicles work?
Yeah, the first step of that question really requires knowing the industry standards, what we call the SAE levels of autonomy. So there's actually 6 different levels, starting with 0 up to 5. And I'll talk through that briefly. The level 0 vehicle is what you see on the roads today. People driving to and from work, going about their commutes and habits. And then sort of level 1, 2, and 3 are hand in hand. And what we see as you go higher up the stack is more and more the system is driving the car rather than the person. So example of a level 2 or level 3 on the advanced side would be a Tesla Autopilot or a Cadillac or General Motors Super Cruise, where now instead of having to be fully attentive on the car at all times, we're getting more and more that the car is driving itself. How I'd like to answer your question today is actually the level 4 of autonomy. And in that case, the biggest difference is the car is driving itself, and also there's backup systems in case of safety. So the final ultimate level, and this is sort of a pipe dream for many different companies in the industry today, is level 5 autonomy, where a car is going down the road by itself. There's passengers or cargo or whatnot, and there's a secondary safety system, but also we're not constrained based on weather and we're not constrained based on geography. But again, I'm going to focus on level 4. And to do that, a lot of companies do things differently, but I'd like to split out and break this down into talking to you first about the vehicle, then about the sensors, then about the software stack. So the vehicles themselves today, you may see test vehicles out on the road, and largely they're just like the cars that you buy and use today, with the biggest exception that they have additional space for the autonomous vehicle hardware. A lot of these cars have safety drivers, and so the systems may be driving the car, and there's someone there as backup. But the vehicles are pretty similar to what we can buy. A lot of companies choose to do electric vehicles, and that's a big push right now because when we move to autonomous vehicles and push out, we have the opportunity to switch over from combustion engines to electric, which can have some benefits both for the environment and also how these will operate. So the second tier that I'll break into is the sensor and specialized hardware on the vehicles. The biggest thing that pops out when you see one of these rolling down the road is the LiDAR, so the spinning laser light and finding. So autonomous vehicles have many different sensors because they're trying to replace the driver. LiDAR, that's the one that has range finding, and you can see how far away objects are from you. A big challenge with LiDAR, though, is having to do with weather and sort of being able to see in degraded environments. So fog or rain are difficult for LiDAR. Cameras, actually, I would say most people would agree that cameras is the most important sensor today. And the reason why is that all that imagery comes back and is fed into machine learning models so that we can classify and understand when we see a person, when we see a dog, when we see a car. And you sort of want to understand what you see, let the card and the system know so that we can then determine what to do next. The third really popular sensor is radar. Now, radar is great for cutting through weather. You can also tell how fast objects are going. But to be honest, it doesn't have as much precision and granularity as cameras and LiDAR. So you can see something big on the freeway rolling down the road, but you don't actually know if it's a semi versus a car. So we have all these different sensors that are specialized and just trying to give the car and the system the best chance to understand what's going out in the environment. The other popular sensor that is actually used on cars today is ultrasonics. You'll see those in bumpers. This really helps with very very slow speeds is where ultrasonics comes into play. This will allow a vehicle to park and also see any sort of shorter obstacles or people around. And then, there's a lot of talk now about using thermal cameras to try and see better in the night. Finally, one sensor that people actually are less familiar with is that a lot of autonomous vehicles today are starting to add microphones. Now, you would wonder, why do you need a microphone? And that's so that when a police car or an ambulance, you can actually hear and identify the siren, or you can listen to instructions from someone in the street. And yeah, that's why microphones are used today. The third piece is the software stack. So now that we know about the vehicle and you know about the sensors, what are we actually doing with this information? And I sort of think about it as breaking down into the different components of the software stack. And this is where the real magic is to make an autonomous vehicle work. First, you receive that sensor data and you have to process it. You have to do something with it. You have to turn those still images in order to understand who or what is around you. Then that is fed into perception. Once we get a profile of what the object is, if it's a person or a dog, those objects then have different behaviors. So a person may be waiting at the side of a corner and know to stop for a car. A dog, however, might actually just run straight across the street. So this sort of the perception stack has a way of figuring out what is going to happen next. One piece I haven't really mentioned yet is mapping. I think people think that autonomous vehicles today can sort of go out and be ready to roll into any city, but that's not the case. We actually have to send an advanced mapping car so that the autonomous vehicle can then check against this map and know where it is at any given point. And this goes back to LiDAR and the real benefit there. After a mapping car has gone down the street, identified certain signposts and banks or certain sort of still locations, when the car goes through, it will then again check these and see these and know where it is at any time. I mean, yes, there's GPS and inertia sensors on the vehicle sometimes for the same localization purpose, but mapping is still required in a lot of these test vehicles. Going back over to the perception side, once you know what is out there and where it's going to move next, you have your own motion planning because you always have to be, as the vehicle, steering around the different things on the road. So if a person is standing on the right-hand side and you want to make a left turn, you know you can safely execute it and the vehicle will know to do that left turn safely, either if you have to wait for the person or not. And sort of going all the way now to, that's the nitty gritty of the software, but we have to get the car to know what's going on. Once you have your motion planning, you actually are then connected to the car's controller in a system called CAN bus. That's how we give instructions to the car about where to move and actually apply the gas. And it's not that there's a robot sitting in the front seat with a steering wheel and operating these pedals, but we're talking machine to machine to get the car to move. So as simple as that was, that is how many autonomous vehicles work today. These three pieces work in concert to hopefully one day have us a driver who's fully attentive and can get us safely to work.
Wow, Adam, that was a great explanation of autonomous vehicles, and thanks for going into all that. I do have a couple follow-up questions that are more related to technical program management as it relates to autonomous vehicles, so I'll go ahead and dive into those a little bit. I want you to imagine, now that we've had an excellent explanation of autonomous vehicles, let's say that you're a TPM at an autonomous vehicle company, or you're working with autonomous vehicles. What are the main trade-offs that you would have to consider, or that you would feel important to consider as a technical program manager?
Yeah, great question. As a technical program manager, I think the most important thing to do is managing the cost, schedule, and sort of quality and performance of your project. An example I'd like to use is if you're a hardware program manager on an autonomous vehicle and you own the compute module or any sensor module in that case. A lot of the times you're working directly with suppliers, and these suppliers want to have a good idea of the quantities that you're working with, what they have to build for you. But a very specific trade-off that you'll have to do is, do you make a system more robust, or do you make it just good enough for the application? And I'll tell you, in the companies that I've worked with, it's no nonsense. The number one is safety. So we will often see, and I would classify safety probably most into quality and performance, that schedule can be delayed and costs can go up as long as we're maintaining safety and improving the lives of the riders.
Totally. Yeah, it's such an important aspect of this type of product that can be different from other types of products. Safety is not really a consideration in other product areas. I want to go on to the next question that I had, just another quick follow-up question around, again, imagining that you're that TPM for this program. What are some communication formats that you might consider when running this program, or how would you communicate across the team?
Yeah, for that, I'd have to look at the TPM toolkit. And there's a lot of different tools out there today. First and foremost, the thing that pops in my mind is sort of regular email updates that you can send company-wide or to your targeted stakeholders about your program. You want to be letting folks know specifically about your schedule and risks that you've identified, and sort of if you run into any obstacles and need to pull in and help. Other ways is obviously in tickets themselves. So popular tools today, Asana, Jira. You're always communicating and using these ticket reference numbers because they have the whole history of whatever the issue is. So whether you're sending it in a direct message to somebody or emailing out, tickets are a great way to only track what your work is and what the priority is, and also communicate that to others. And then, of course, there's meetings. And we've been doing a lot of Zoom and online meetings today. You can set different meeting cadences for that. In my past projects, I've presented to the CEO and CTO on a weekly basis about what the status of this critical part is. And you have to tailor your communication style there a little bit. Executives want to know just what the sort of high level points are and how it's going to impact the program as a whole. And then you have all of your regular syncs with the individual contributors on your team. So now this is when a TPM has to roll up their sleeves, go in with the engineers, and really just let folks know what is blocking who and sort of what the priority is at any given point. So I think within all these different tools, and any great program will use maybe all of them or some of them based on what the complexity is.
Awesome. Well, Adam, this has been great. I want to move on to talk a little bit about feedback, and you can kind of take off the interviewee hat in just a moment. But is there anything else you'd like to add to this particular interview answer?
No, I think that really is what it boils down to. For this type of questions, I think it's really go back to the fundamentals of the TPM function itself and make sure that you're covering all the bases, because the most important thing that TPM can do for their program is, one, really clarify communications, two, be a constant, positive force and reinforcement for the whole team, and three, ultimately, you have to having someone be accountable for the success of the program. These three things are what make TPMs great.
Totally, yeah. Overall, excellent answer, Adam. This is super awesome to hear, and I think will be super helpful to all the TPMs watching. I do want you to take off that interviewee hat, and maybe we can reflect together about, I know you just gave a little bit of your self-reflection. I wrote some notes about what I thought you did really well and what I thought made this answer such an awesome answer. One, I thought you used frameworks judiciously throughout this answer. So you brought in like TPM toolkit, or hey, cost, schedule, quality, and performance are factors I'd consider. But you did that in a very not a very overbearing way. So sometimes I often recommend interviewees to avoid using frameworks because they can often rely on them too much. You had a very natural cadence. You were talking through things, you were enumerating them, like this is the first point, second point, third point. And you did a great job of sort of like level setting like where we are and making assumptions about what I was looking for. We're not looking for a level 0 to a level 3 vehicle. We're looking at a level 4 or 5. And kind of discussing those and making those decisions yourself. I thought that overall led to a great answer. I know we're in a little bit of a contrived setting, but the only piece of feedback I had would just be checking in with me a little bit more as your interviewer. It's always a conversation, not just a one-way direction, and sometimes it's easy to kind of get carried away. I personally thought it was so engaging and you did such a great job that I almost didn't really want to interrupt you, but in an actual interview setting, it's always helpful to check in to know how long the interviewer actually wants you to go. But overall, I thought this was a really awesome answer. You did a great job articulating your perspective on this, and you clearly are an expert both as a TPM and in the autonomous vehicle space. But I did want to leave room if you had any other comments, reactions, maybe even tips to folks watching that you wanted to share at the end of this video.
Oh, certainly, I agree with everything you said, including this critical piece of feedback. Um, yeah, it's a different world right now than when we've been interviewing, earlier this year. Doing Zoom calls and interviews, it's challenging sometimes to get that back and forth in. But yeah, you bring up a great point that it's good to check in. Sometimes an interviewer is asking a question and they want sort of a 1 minute response. Sometimes they want something longer, and you look for cues from the interviewer based on how complex and how deep you should go. And just like you mentioned, yeah, it's always good to check in because I could have stopped at autonomous vehicles, vehicle sensor, and software stack. And then only then, once an interview want to dive into one of those disciplines, go deeper. Um, yeah, I agree with all that. And I would say for TPMs, like you were mentioning, frameworks are very important because they're looking for you once you join the company to see that you can apply those things. And throughout the interview process, whether it's coordinating with a recruiter, whether it's answering questions directly with people who are going to be your partners the next day, yeah, knowing that you can not only know what these frameworks are, recall them, but actually use them fluidly is vitally important.
Totally, Adam. And just for folks watching, I think a natural follow-up question is where do you learn about these frameworks, or what are some of the frameworks that you think were most effective for you in interviewing?
Honestly, with a TPM, the best way that I've learned is on the job. So I think for me personally, having this unique experience working again in government, consulting, and in tech now has really made it easier. But you need to be talking with other TPMs. I feel like that's what's missing today. You see online that there's a lot of resources and groups and prep for product managers. There just really isn't as much out there for technical program managers. We do have certifications like the PMP, which I'll be honest, I'm studying through now. I haven't attained it before. But that teaches a lot of sort of by the book and these different structures. But yeah, the best way I've learned is working and also meeting with my peers and colleagues.
Awesome. And we'll be adding some of the notes from Adam's conversation today to the lessons in this course as well. And just again, thank you, Adam, so much. This is super, super valuable for other TPMs out there. And I appreciate you helping us grow a community of TPMs to help prep and ace the interview.
Yeah, absolutely. Thanks so much for your time today. And to all of you out there, good luck.
Great. Good luck on your upcoming interview.